Hello everybody. In this video I'll talk about frequent pattern growth algorithm. This algorithm is used for finding association between objects. Association analysis is the process of finding a relationship between two or more objects or their attributes. Market basket analysis is an example of finding association analysis between the products that are purchased by customers together. A priori algorithm and frequent pattern growth are two algorithms to find association between the objects. A priori algorithm suffers from two problems. In case of the a priori algorithm, huge number of candidate sets may be generated. If there are 10,000 one item sets, then a priori algorithm will generate more than 10 to power 7 candidate item sets. That means huge amount of candidate item sets are generated and huge amount of memory space will be required to store that item sets. It needs to repeatedly scan the database and count the frequency of candidate item sets. In a priori algorithm, database or the original transactional database is inquired frequently to know how many times the candidate item sets are repeating. So that is a very time consuming process. So because of these two problems with a priori algorithm, another algorithm being generated, that is the frequent pattern growth algorithm. In that algorithm, database is scanned only once, and in the single scanning of the database, frequent pattern tree is created, and from that frequent pattern tree different patterns are generated. Now let's see how to create frequent pattern growth tree. Now let's consider a simple transaction. I have created a very simple transaction here containing 5 transactions, T1, T2, T3, T4, T5, and it is having 4 items only. In the case of the first transaction, there are 3 items, in second 2 items AC, in third BC, and so on. Now first what we do is we will find the individual items. The individual items are A, B, C, D. They will count how many times these items have repeated. From our transaction we can see A has repeated 4 times. 1, 2, 3, 4. Similarly B, 1, 2, twice. C, 1, 2, 3, 4. In this way we will figure out the frequency of each item. Then what we do is we will rearrange these items in each transaction on the basis of frequency of these individual items. That means we will rearrange these transactions so that the items with higher frequency will come before items with lower frequency. So after rearranging, what we will get is ABC, that is in the original database. In the first transaction, the first record is ABC, but after reordering we will get ACB because frequency of A is highest, for C, for B 2. So we are reorganizing these transactions. Here we can see in transaction 3 BC is written in original, but after rearranging it will become CB because C has highest frequency, that is 4, and B has frequency of 2 only. So 4 comes before 2. So in this way we reorganize the transaction on the basis of frequency of these individual items. Then now let's see how to create the frequent pattern tree using this ordered transaction. Now here we will initially creating a node, that is the root node null, because there is no branches. So first we will consider the transaction, this one, the first transaction ACB we will consider. Now we will start creating a branch from this null. So let's take this here. Now the first item of our transaction is A. So let's put this A here. A, then there will be another branch, that is from A we will get what? C. So let's put C here. Then another branch here we will get. Now another item here is B. So in this way we will create the branch that we consider the first transaction. Then we will specify count for each of these items. So A initially will be 1, Now C will be also 1, B will be also 1, so there are 1 1 1 at the when we consider this first transaction. Now we will consider the second transaction. In case of the second transaction, the first item is A, and we already have branch which starts with A. So what we do is we will increment the value of value of A by 1 here. Now after A we are having C in this branch, and in this transactions also we are having C. So after A there is C, so simply what we do is we will increase the count of C also. Now let's consider third transaction. In case of the third transaction, transaction starts from C. Here in our tree we are not having any branch starting with C, so we will create new branch here. So we will create this branch. So after C we are having B, so we'll put B here. Okay, Control V. Now we will initialize the count of these variables also, this node also, these items also. So in this case all are 1 1. Now we'll go to the fourth transaction. Fourth transaction starts with A. Now we are having branch starting with A, so we'll increase the value of A by 1 here. Now after A we are having C in this branch, but in this transaction we are getting D, so we are supposed to create a new branch from A, and we will add D here, and we will give this count for D also. So in this way we specify the count for D also. Now there are no other items in this transaction. Now we will check this last transactions. In this transaction we are having ACD, we have branch with A here, so we'll increase the value of A here, and after this we have C. In our branch there is C, so we don't have to create new branch, we simply increase the value of C here. Then we are having D. After C we are having B here, but there is no D, so to show D we will create the new branch from here and add D here, and we will provide the count for D also. So in this way we create the frequent pattern tree. So now this tree will be used to create the conditional database from where we can generate different patterns. Now let's see this. Okay, let's make, I have created this pattern database already in Excel, so let's decrease the size here a little bit. Okay, now we will create this conditional pattern base using like this. Okay, we will take these individual items on the basis of their frequency in the ascending order. We know that D is the least seen object, B is the least seen object, after D, C, then A. That means D has frequency of 2, the least, so we started D here. B is the second one, so second least frequency item, so we started B here. C is the higher than B, so we kept C here. So in the ascending order 2 to 4, we don't have to consider A. Now we will see in the tree how can we reach to the D. So here in the tree we can reach to D via A. So the count of A, D, and count of D 1 here, so we'll write A 1 here. You can see we can reach to D from this path also. The beginning nodes are A and C, the count of D is 1 here, so we will write AC1 in the conditional pattern. From the tree we see that D can be reached from two different routes, two different branches, that is using branch A and another branch is AC, and for both we are having 1 as the count. So conditions for reaching D are A colon 2, C colon 1. We can reach D from A because there are two branches and both branches have A, so there are two branches in case of A, so we are writing 2 here. And for C there is only one branch, so we are writing 1 here. So the frequent pattern that can be generated is, we have seen D 2 times. Here we can see there are two conditional trees from A and C we can reach to the D, so we are having a pattern AD2, that is we can reach D or via A and via A comma C. So the frequent pattern generated is A2. If the minimum support for this transaction database is 2, in this case we can say AD is interesting pattern because AD occurred twice. Similarly for the B, we can see how we can reach to the B. From this path we can reach to B via C, so C is 1, and in this path AC B we can see that using A and C we can reach to B, so AC 1. So in this way we can reach B to, we are having two different branches to reach to B. So in this case our minimum support is 2 and A occurred only once, but in these two paths we can see C, so C occurred twice. So our conditional pattern for B is C2 only, because A we cannot include because A has count of 1. So in this case we can write A also because that is not A colon 1, also fine. Then with the pattern we can generate it is CV only, because A doesn't occur twice here. C occurred twice, C occurs in two different branches and B are seen in both branches, so we can generate the pattern CV, which is interesting. Similarly in case of the C, we can reach C via A only, from this path only, A, C. So but how many times we can reach to C via A? That is 3 times. C 3, but A occurred 4. So the branch which we can use to reach C is AC, and that branch repeated for 3 times. You can see the count of C is 3. That means this AC is repeated 3 times. There are 3 branches but represented by same branch. So conditional pattern is A3 and conditional FE3 is again also A3. The pattern that can be generated CA3. We are finding CA in 3 different branches, so that 3 is greater than our minimum support, so we can say AC also. Very interesting. So in this way, using this frequent pattern growth tree, we can generate association between the items. The major benefit of this algorithm is that we have to access this database initially to find the count of individual items and then to create this tree. Only we will be accessing database for 2 times. Then once we have created this frequent pattern growth tree, we can generate all the interesting patterns exist within the database. So this frequent pattern tree will be efficient compared to a priori algorithm. But this tree creation will be a very time consuming process. Once the tree is created, we can easily generate the patterns.